What's up, nerds? Harbinger here. Here's video 2. This is probably going to be a little bit faster because I assume you've already watched video 1. And if you haven't yet, go back and watch it. Don't forget to hit that don't forget to smash that subscribe button. I don't know what's wrong with me. This might be a little bit more disjointed because now that I feel like we've got like a fundamental understanding of loops, I can move a little bit faster on some things, but I'm not just going to play it off like, hey, this is really easy and naturally you get everything because I'm such a good teacher. This is really difficult. And the more we work at it, the better we get at it. So I'm going to do one more thing that crosses the language boundaries, and then I might show something fun. If you hear the bell go in a second, lunch is about to start. I'm giving up lunch to make programming videos. So, hey, there's that. So I'm going to do a countdown really fast. You know, we could sing a song like 99 bottles of chocolate milk on the wall, 99 bottles of chocolate milk, because, you know, that's what you'd have on the wall, chocolate milk. But instead, I'm just going to do a regular countdown. I'm going to move a little bit faster just because, you know, people have kind of seen it already. So I could leave some comments like, hey, program by M. Harbinger, it's a countdown or whatever. We could add things if we really wanted, but I don't want to count down from 10 down to 1 or 100 down to 1. I mean, that's cool and all, but I'd rather not. And I want to do something else that's more functionally interesting, like prime numbers or whatever, but that's kind of on your homework, and so I don't want to just show it now and, you know, spoil that. So I'm going to count down from 10 down to 7 or from 100 down to 2 or whatever. I want people to see that it doesn't always have to be like a one boundary. So what I'm going to do is I'm going to do like start, and I'm going to give it an initial value like 100, and I'm going to have an end value like I don't even know what, 19 or something like that, just because it's a little bit strange. Lunchtime. That being said, I'm going to loop. I'm going to count down from one down to the other. So where am I? I ask that all the time. In range, and I'm going to count down. So I'm going to start at start. I'm going to end at end. Weird, right? Funny thing is I could actually flip-flop the variable names as long as the functionality is good and I'm careful about my variables. It doesn't matter. But I am going to count down like this. So I'm also doing something wrong there. I'm okay with that. I want to show you. Where am I? So I hope you remember the other video. And you're going to see it go 100, 99, 98, 97, all the way down to 21, 20, and stop, right? That last value isn't typically included. Oh, I'm not always right about things, but apparently I am here. So I'm going to put a -1 here as an offset. And that way I get 19 included. That's a standard for loop, but it's subtracting, which is fine, right? That's kind of what I wanted here. And so that works. The funny thing is, I would want to do this all over again. I could print where am I and show you that it's really 19, but it won't work. For now, understand please, because some of you were going to ask, like, hey, I tried to use where am I afterwards. And, oh, shows what I know. Variable scope, Python, LOL. Hey, it stayed at 19. That's a good thing. I'd love to be smart for like a day. Oh, well, I am going to count down using a while loop. So what I'm going to do is say while start is greater than equal to end. And start. And I do have to subtract 1 from start, because otherwise I'm going to get an infinite loop, and that's not very fun. Watch this. Hey, it went from 100 all the way down to, you know what, I'm going to scroll it if I can. You know what, I'm not very smart. So instead, you come back up here. I'm going to change the start value to like 30. And if you see, it goes 30 down to 19. That's great. I'm really happy. What if I switched the order? Right? Because that shouldn't matter. It just loops. Right, bro? Wrong. Hey, it went down to 18. Uh-oh. It does matter. Order matters, right? So in a loop, you're like, hey, is start greater equal to end? Yeah, it is. So let me drop it down to 29. And I should be printing 29. Why would it print 30? Oh well. Loops get weird, and it's messing up, and I'm not exactly sure why. Oh well. Hey, Python loop stuff is kind of weird. I do, though, really want to show it translated into computer science principles without spending like 1,000 IQ points on it when I already have like not much. I guess is the nice way to say that. So I'm going to do it in a computer science principles notation. Here goes. I need a variable, and I'm going to call it start because that's what we called it. And this I'm going to set it to 30, and I'm going to have a variable called end, and I'm going to set it equal to 19. So far, so good. And what I'm going to do is I'm going to repeat until, unless you want to repeat num times, but that doesn't really make a whole lot of sense here for me. So I'm going to do repeat until. Spelled it better, that'd be better. Start slow. There we go. Can I spell end correctly? Getting better. Okay, now I'm going to display. And I'm going to display start. Now I'm going to drop start by 1. Nice. That's better. Some people will prefer to count end up. That's actually kind of funny because if you do that, it's still just going to print, like if you did that instead, it's going to just print 30, 30, and 30, and 30, and 30, 11 times or 12 times. So it's funny, but it's an error people make. It's called a logic error. Your computer doesn't recognize there's something wrong. It's just going to do what it's told to do. So we have to be careful about our variable assignments and our variable operations. The funny thing is, if you let this one stay and you ran it like this, it's going to print 30, and it's going to drop end. So it's going to drop start down to 29, and it's going to bring end up to 20. And then it's going to print 29 and drop it down to 28, and end jumps up again. And so it actually prints in descending order, like 30, 29, 28, 27. But it doesn't get all the way down to 19 because end is moved up and up and up, and it meets somewhere in the middle, and it only runs like half the time you thought it would. So just, again, be careful about variable operations and what you're really doing. And like I said before, order does matter. I'm not sure why the other loop was acting up, but we're going to practice it between now and then. So one more thing I wanted to show, and this involves turtle stuff. There we go. So I'm going to import turtle. All in caps, of course. Import turtle. There we go. Getting better. And I'm going to make a turtle, and I'm going to call it T because it's fast to type. Now, if I wanted to do something, I could say something like, hey, for x in, I'm not going to call it x here, num in range 100, and he could do something 100 times. I don't even know what. He could t dot forward 1, and then t dot right turn, I don't even know what. Let's do a random number. Random dot rand int negative 180 to 180. That seems like fun, right? So really what my hope is here is that the turtle moves forward 1 and then randomly turns left or right, some degree measure, and then just repeats the process. So you got this tiny little drawing going on there. Let's change this forward value to like 3. He's making a squiggly line. He's randomly choosing a direction, and he's kind of like staggering around. Like he bumps forward a little bit and turns, and then bumps forward a little bit, and then he turns. And he could, in theory, just not move at all. He could, in theory, just constantly go straight if he turns 0 100 times. That's fun. This is a famous computer science / math problem. At the end, how far do you expect him to be from the starting point? I would assume 0. It's going to average out in the long haul to end where he started. So this is fun and all. I'm just trying to show you like fun uses for loops. But that's a for loop. We ran it 100 times. What if I wanted a while loop here instead? I'm going to do something equally fun. So here goes. While t dot x core, and this means his x coordinate. So right now it's 0 when we start, is greater than negative 100. I'm going to keep him in a little box. And t dot x core is less than 100. So far so good. And t dot y core, it would be his y coordinate, and it's less than 100. And t dot y core is greater than negative 100. I don't expect you to know what I'm doing. I don't expect you to know that core, x core, y core, get the coordinates. I don't expect you to know about and yet. But hey, while I'm not too far out, while I'm relatively close to where I am, I'm just going to keep moving. So t dot forward, this time I'm going to move him forward like 8 or something like that. And then I'm going to have him turn that random direction again just because it seemed like a fun idea. So right turn, random dot randint, negative 180 to 180. You know, it was kind of funny to watch him stumble around. I'm cruel like that. So in theory, I could go to lunch, come back, and he's still just bumping around inside the box. So that would work, although in practice, eventually we're going to get lucky enough that he's going to get to the edge of the 100 or the negative 100 or the 100 or the negative 100, and then he's going to like push past it and the loop's going to stop because he made it too far. So I don't know if I have the patience for this, but again, I could just bump up his forward value, right? I can make him go forward 20 every time or something. But he could, in theory, be running forever. And that's the joy of a while loop. Hey, while these conditions are true, do this. Whereas a for loop tends to run this many times, and that's just how it is. I'm watching him jump up. See? So if you're watching the screen, he finally hit that upper boundary. He crossed it, he turned, and he stopped. So maybe it ran 100 times. Maybe it ran 1,000 times. Maybe it ran 32 times. I don't know. How could I tell? Oh, I know. I could declare a variable up top, num of steps, let it run down here, and then print it at the end, right? That'll be my last thing for this whole lab. In terms of programming things. I do have one more point to make, but, you know, I might leave that as a question at the end. So num of steps, and I'm going to set it equal to 0. And every time this loop runs, I'm going to keep track of it. Num of steps plus equals 1. And at the very end, when the loop is done, that's when I'm going to print it. Num of steps. So what I am going to do is I'm going to move this up a little bit just because I don't have the patience to watch it, even if it goes like 2 hours. So while we're watching that thing move around, it seems to be doing a pretty good job. Looks like some kind of like abstract art going on. And we could change its color and the pen thickness and all that, but it's a horse of a different color. I guess my final point is going to be, you should be wondering right now, so if a loop does something repeatedly, what happens if you put a loop inside another loop? Is that even possible? And I'm going to make like a dead meme joke because it's October. Yo, dog, I heard you like loops, so I put a loop inside your loop so you can loop while you loop. Memes used to be a thing, and they used to last longer than like a week and a half. But anyway, yeah, you can. And maybe in the comments below, you can leave an example of what might be a good use for a loop inside another loop. Turtle stopped moving. 107 steps. So it wasn't 100 exactly. If I ran it again, it wouldn't be 107 in all likelihood. It might be, you know, I don't even know what, 7? It could be 1,000. That's the joy of this. Other than that, hey, I'm glad that you got to watch some of the cool Python stuff in terms of the turtle graphics. I'm glad that we did the other loop thing, even though the one thing wasn't working like I thought it would. Homework is coming up soon on this. And after the homework, then there'll be a quiz on this. And I hope your graphics programming is doing well. Harbinger out.